All right, welcome. This is the sixth live class, and this live class we're going to look at how to create a database using business requirements. We're going to cover topics from weeks 4 to 7, and I will advise you to watch your pre-recorded videos as you get a little more details. And then in part 3 of this course, we are going to discuss same topics but in advanced details. But for now, we're going to look at those topics to help you, especially in assignment 3. So in our last live class, we looked at what storage engines are. We looked at character sets, and we also looked at how to create a database. We discussed creating tables. We look at the different data types or the different data types we can put on the columns when we create our tables, and the different constraints that we can enforce on the different columns. I would advise you to watch the previous live class recordings if you are behind, before you follow up with this one. We're not going to repeat that. We're just going to go ahead and create a scenario and then try to work with that scenario to create a database. So let's assume that we have been asked. And before we start, let me tell you this. Most of the time when you get requests from people for something that they want you to create in IT, most of the clients, they never know what they want. They have an idea, like a high level idea of what they want, the functionality they want, but the job is on you, the developer, to give them details about what they want and tell them what they need, and also be able to, from their high level requirements, be able to create a business requirement, maybe for their approval, or a prototype to demonstrate, so you can get a whole functional specification of that high level requirement. So the clients will never be able to give you full details, except if they have an IT unit that creates detailed business requirements. But that is the reality in the real world. So let's say there is a client who has told us that they want to have a website, but this time what they want us to do is create a database that will handle holding all the data information for registering patients, for scheduling appointments, and for recording all of the clinical encounter notes for each patient. This is the only information they've given us. They're not telling us what other functionalities will be there. But as a developer, this is where your critical reasoning comes in. So you only know that you need to create a database that will hold this information. This is where you work with backend developers, the ones who write the script, and the people for the front end, to see the fields that the forms will have, and then to know which database table or columns in the tables that this goes into. In part 2, that will start next week, we're going to see how to actually do all of that. And by part 3, when we begin to build the whole system, you'll see how we'll create a model and then build forms out of the model that we've created. So right now we have this information about the client wants us to create a database where we will store patient information. The information they want to store is registration of patients and their appointment scheduling and recording of the clinical notes when the patient comes into the clinic. We want to now start reasoning logically to see how we can build this into a requirement, to build something that will keep to the ACID properties, which means that all the tables should be related, there should be integrity, and we should have columns for everything we anticipate that is going to be created on the form. So the first thing we want to think about is, when you have a database, you're going to have rows of different people. And when these different people log in, they should have different functionalities that they can access. For instance, you won't want a patient to be able to access clinical notes of other patients. So we restrict this by roles, and sometimes within the roles we'll have permissions, so that even if they assign the patient role, there'll be different levels of permissions. The same thing with administrators. When we have administrators, we might have administrators who do not have the legal rights to view patient record, and maybe all they want to do is to deal with recording vital signs or recording patients when they come into the clinic, and we want to put that permission for that administrator. And then for the administrators that we think maybe one of the admin is a doctor who we think will record clinical notes, will have the permission of recording clinical notes also And so on their pages, when they log in, what they will see is what permissions that they are assigned to. But you don't have to think into detail how their page will function. We only have to think about how to build this. So we now have an idea that we need to have the different roles defined. We need to have permissions within these roles that we have defined. And we need to define the permissions, associate them to a role. And when we want to associate two things together across table, we will use foreign keys. We also want to note that when we have the roles and the permissions, we have to have a table that holds user information when we register these users and assign roles to them. We want to have a table that holds all the permissions that a user is assigned to, so that when they log in, the system checks that table to see what permission they have, to see what drop-down menus to release for them to be able to view on their page, whether they have access to perform the requirements for those things. So the first thing we'll do is to create a database, like we looked at in the last live class. We'll create a database specifying the character set and the collation that we want. And so we'll write it like this. Create the database, and we say we want to use good want to learn in the proper way. We use if not exist, so that in the events that it exists, it doesn't show errors or stop the flow of anything, because we want to tell it if it doesn't exist, just ignore it. If it exists, just ignore it. If it doesn't exist, create it. So we say create database if not exist. Let's give this database a name. Let's say we want to create, let's just call it hospitals for the purpose of this demonstration. So create database if not exist hospitals. We want to set the character set. So we'll say character set. And the character set we want to use, let's assume we're going to cater for a lot of languages. We'll say UTF-8. So UTF-8 and before. And then we want the collation, which we'll specify using collate. And we want it to UTF-8 MB4, and then Unicode TI. And then now we put a semicolon. So this is how we create a database. We use the create database statement if you don't want to have errors that will halt the process. In the event we're writing just one script that we want to run to create both database and tables and insert records, we want to put all of these conditions there so that it doesn't stop the flow of execution. So we create database. If not exist is optional, and you can add it. It's a good practice to always add it. And then the name for the database, you specify the character set, and then the collation, and then you use a semicolon at the end. And then when you click on go, it should create a database. When you get a green check mark, it means that this has been created successfully. So we have a database called hospitals now, and it's within this database, when you say use hospitals in your MySQL workbench, that we want to start creating our tables. So any questions before we move forward? Okay, in the absence of questions, let's move to creating the table. So now we have the database created. We want to now create a table that will hold the rows, so that when we want to assign roles to users, we only just select from the defined roles from that role table, which is the best practice. You don't want to have free field to define roles, or you have problems in your system as a whole. So we created a database. So now we want to create roles that we will use. So we'll say create table. So we create a table using the create table statement. Also, we'll add the if not exist. So create table if not exist, and the name of the table we want to create is called roles. Then in a pair of parentheses, you put the semicolon at the end, and then within the parentheses, you define the columns. Before the semicolon, you can also specify the engine. This is where we specify the engine. So the engine will be equal to, we say InnoDB supports foreign keys, which we are going to be using a lot here. So let's say InnoDB, and we want the default collation. Let's say default. So we'll say default. So we'll do the default character set before the collation. So default char set. and we want the default child set to be equal to UTF-8 and before, and then we want the collate to be equal to UTF-8 Unicode CI. Now, the importance of this is when you start building enterprise systems or very large systems, there are some tables that might actually hold different child sets and collation from the database itself. This will create conflicts when these tables are linked with foreign keys. So you don't attempt to do that until you get that advanced to be able to understand the do's and don'ts when things will affect other things. But for now, we are going to make all of our engines InnoDB because we want it to support foreign keys and transactions. And then we're going to keep the character set to be the same as the character set of the database, and the collation has the collation of the database. So this will be UTF-8 and before Unicode CI. Okay. Now we are going to create a table called rows. And what do we want the columns to be? We want an ID column that will be the index that will auto increment. So we want this to be an int, and we'll set auto increment. So we'll just put auto increment. And the reason we do auto increment is we don't want to insert values into this particular column. We want it to automatically increment. So the first one will be 1, 2, 3, 4. So we want it to do it automatically, and it will be the index, it will be unique, and it will be that unique key that we use to index the rows for once. But I just normally use ID. It mustn't be ID that will be the primary key. You can use row ID instead of ID. So I'll set this to be the primary key. Writing primary key. So primary key enforces not null and uniqueness on a column. We want to actually have another column. Let's call this the role ID column. Role ID, written like this. And we want this row ID to be let's say varchar, in case if we are going to be using alphanumeric characters for ID. And let's say we'll use, let's say 10. Let's say it's going to be maximum of 10 characters. So row ID varchar 10. We want the row ID to be unique, so we can put the unique constraint here. And then we also want it to be not null. Now take note that I'm using the easiest way for you to create tables. There are ways you create it that you specify the constraints at the end and you name the constraints. If you watch your pre-recorded videos, you have that there. But in this live video, I'm going to break it down easy so you don't get overwhelmed. And as you go deeper and advanced, especially in part 3, you can begin to do things in a more professional and complex way. Then we have the row, where we define what the role is. So let's say the rows, let's just put maximum of 20 characters. We also want this row to be, or let's say 40, just in case. We also want this row to be unique, the name of this row to be unique. We want it to be not null. And we also want to specify a default. If a role is not given, we want it to be by default be an admin. This is risky. To make the default person an admin if the role is not given. Since it's not null, we want to specify a default value. I just want to show you how to specify default values, but you can leave it blank actually. So we had this created. Note that in the after the last column, you don't put a comma, you just stop like that. So we've had this rows table created. We want to create another table for the permissions. So we'll say create table if not exist, permissions, and then when we have the permissions table, we want to think about these permissions are going to be associated to a role. So we want to have, let's say the system has role-based authentication and permission-based authorizations, which means that once a person is assigned to a role and the person logs in, the person will be welcome to the home page of the assigned role. Within that role, the permissions that the person is assigned will control the functionalities that the person can perform. So this is the structure we are trying to adopt. There are many structures that will be based on your business requirements in the future. Some sites only have permissions defined. There are no different roles. They just assign permissions to different people. You can do role and permission access if you have different categories of users. So we're going to use the role and permission to do a different method of authentication and a different method of authorization. So our permissions will control authorizations and our roles will control authentications. Okay. So we have the permissions table. We want to have an ID the same way. We say this is int. We want to auto increment. And then we'll say this is the primary key also. We want to have permission ID. So you can skip having an ID and use the permission ID as the primary key if you choose to, but I'll do it this way. So we'll have voucher. Let's say we want the permission ID to be just like the rule 10 characters maximum. We want it to be unique, and we also want it to be not null, which means a value must be entered. We want to have now the name of the permissions. So let's say the permission, let's say this is going to be a variable character, and let's say it's going to be of length 40, or let's say 50. And then we want this also to be not null, and we want, let's put a default value here, a default to be or, which means the person will have access to all the permissions. Then now this permission has to be associated to a role, which means we have to have a role column or any name you give it, but just know that your foreign key means that this is a parent to this. So you can name it role or role associated, whatever you want to name the column, but there are some rules you must keep to. Let's make this the same voucher 40 as the main role there, and we want to make this not null. Ideally, you are going to link this to the role ID and not the role itself, but I'm going to link it to the role because linking to the role ID is pretty easier and straightforward. And linking to the role, I want us to be able to look at the examples and see how this presents. So now that we've linked this to a role, we need to have the foreign key constraint defined. And so we do that by saying foreign key. And now the foreign key is going to be the role column here. So when you put foreign key like this, you specify in a pair of parentheses. I think my foreign spelling is wrong. Is it E before I think? Yeah. So foreign key, you put the column that is the foreign key here. Without a comma, on the next line or on the same line, you want to put the references. References specifies what table this is a parent for this foreign key. The name of the table is the rows table. And when you put a table name, you want to put in parentheses the name of the column that we are referencing, which is the row column of the rows table as a reference. We want to also specify what happens when you update this row parent. What do you want it to do when it's updated? We want it to cascade, which means when this is updated, anywhere role is referenced, we want to update automatically. So it keeps to the integrity of the table. So it's not like when we update row, then permissions will have a row that we no longer have on the row table. But when we use the condition on update, cascade, which means that once you update the parent table, updates this table also automatically. So if we change the name of the role here, it will change on this table automatically. So you update parents and all of the children are updated. We want to specify what happens when we delete it. When that role is deleted, we want to specify whether we want to also delete it or the occurrence of the role from other table. There's no comma here, sorry. On delete, you choose what you want to do. Okay. Apart from cascade, what you do is restrict, which means that when you put restrict, it means that do not update this table when the parent is updated. There are instances where you have to use restrict, especially when you are trying to delete a user and there are patient file associated with that user. You won't want to cascade the delete. You will restrict delete. So only that user will be deleted, and then everything that the user have done, the files they've created, the patient record will not be deleted along with that user. So that's where those are the instances where you use restrict on delete. And most of the time we use restrict on delete, but this is roles and permission. If the role no longer exists, we don't need to have permissions under it. So in this instance, we want to cascade down. And once we do this, we can still copy this engine stuff instead of rewriting it and putting it here. Okay, we've created the role, we've created the permission. Let's see if all is well with this creation. I'll click go to run this to see if all is well before we go further. So now we have the green check mark for both, which means that the both have been created correctly. When I look at the permissions, I have this created. When I look at the roles, I have it created. We don't have any record on this table, but we're going to insert records using transaction later on. But we have those two created. Now we have the role, we have the permission. The next thing we want to think about are the users. Where do we store the information of the users and the permission of the user? We want to create two extra tables. One to store registration of a user, and the second to store all the permissions that have been assigned to that user. Okay, we're breaking them into two separate tables. Any question before I continue? Okay, so we're going to create a table called users. So the same create table statement. So say create table if not to exist, users, and then let's put the engine here, and then we want to put what columns they will hold. So we want the ID to be int auto increment. We want it to be primary key. Okay, we also want to have the user. Let's say the unique ID of every user will be the email address, since emails are unique. So we'll say want email, we want it to be virtual. Let's say 200, just for the purpose of normally you store these things encrypted, and so when you encrypt you might have longer characters. So let's say 200 variable character. Let's say we don't want it to take null values here. Okay, and then we want emails to be unique also, so we enforce unique constraint. Then we want to create place for their password, where they can put their password, so the system can verify the email and the password before login is successful. Let's make this varchar 200 again, and we want to make this it can be null. We can allow null for password here, and let's say default is null, no value specified. We want to have the role that we want to associate for this user. We will use varchar 40 like it is on the role, since it's going to be a foreign key, and this should also be not null because we want to also specify the role on creation, which means that this is a foreign key of the parent table roles. So we're going to use the foreign key constraint there. Let's say this is all we want to create for the users table. They have an email and a password that they will use to log in, and then they have a role defined. Now we want to define the foreign key. So foreign key here is going to be the role. Every time you are using a column that exists on another table, that column is a foreign key, and you have to reference where that foreign key is coming from. So references is coming from the rows table, and the column within that table is row, and you want to specify what happens when you update and what happens when you delete. So I'll say cascade, and on delete, this is one example where we restrict, because you don't want to delete a user because the role has been deleted. Okay, what we want to do is to null that role if it doesn't exist anymore. Okay, so have done this, let's hope that this works. We'll go ahead to create the user permissions table, and then we'll run both of them to see if they work, and if there's an error, we'll correct it. The next we want to create is a table that holds the user permissions, the permissions assigned to the users. So create table if not exist, and the table we want to create is called user permissions, written like this, and then we want to do something. So I'll copy this engine also instead of typing and put it here. Okay, so user permissions, let's say we have an ID just for indexing purpose, also increment, and this will make the primary key. We have the user permission, the email that this permission is assigned to. Let it be exactly this email. And then we want to have the permissions now. This will take a comma separated list of permissions. So it's not going to be individual permissions. So this is not going to be linked to the permission table, because we are going to have the permission as a text. So in case the person has too many permissions, it's not going to be just a variable character. It's going to be a whole text field that can take a lot of permissions in the event where there are 100 permissions and you want to assign all to the user. Okay, except if we define something called all, which means that all permissions are assigned. Okay, but we want the permissions to be a text like this, and we want to now, let's even say the permission is not null, or let's leave it null for this. I want to define the foreign key, which is the email. Now this email should be linked to the primary table of the users, so that when the email address of a user is updated, you want to update it on the user permissions table, so that the integrity of the table will be kept. So it's not that when the email is updated on the user permission table, that email no longer exists, so the permissions no longer apply. So no, we want to create those links and keep to integrity of the table. So we'll say foreign key, and the foreign key here is email, and references is from the users table, and the column called, so the table name is called users, the column name is called email. We want to see what happened on delete. If you delete that user, we can delete the permissions because the user is no longer there. And if we update, we want to update also, we want to cascade. Okay, and then this is the user and the user permission table we just created. When I say go, all is well, we have 2 green checks. Any question? So does everybody understand so far?
Yes.
Yes.
Okay. So using that simple business requirements, we've used our logical reasoning as developers to know all the things that are needed to make that high-level requirement work. And the things that are needed are, we want they want to look at the access type of how users log in and when their accounts are created, where their record is stored when they create their accounts, what roles are assigned to them, what permissions can they have, what functionalities can they perform. And then we also want to look at other tables that will store other information like the appointments, the vital signs, the clinical notes. But before we do that, let's try to insert values into these roles and permission tables, and then maybe insert values for the users, and then we'll try to, and the users and user permissions, and then try to do other stuff. So in week 4, we looked at transactions, and I'm going to look at an easier form of transaction in this video. The transaction will make more sense when we do things like stored procedure later on, where we want to look at how to roll back if something doesn't happen and how to commit if that thing happens. But transaction basically controls like a group of things should happen together or fail together. So if we want several several insert statements across different tables, we want it to all insert together and commit at the end. And if one table fails to insert, we want to roll back if that doesn't happen. By default, MySQL commits everything that we do. It creates it, so it's wrap around the begin and start transactions, and it commits automatically. We want to remove that automatic commit, and we use set auto commit statement like this, and we set it to either 0 or off. You can say set auto commit 0 or set auto commit off like this. I'll use 0, and when you want to turn it back on, you use 1 or on. By default, it's on. When we do this, we want to start transaction like this. So the start transaction statement will tell you that we've started transaction, and that transaction is not going to save in the database until it sees a commit statement at the end, or it sees something we call rollback at the end. Rollback is when one of them fails, maybe one of the insert fails. You want in one table, you want it to roll back. You want it to commit if everything commits. So we're not going to use rollback now. We'll use it in part 3 when we look at stored procedures and how we will commit if everything is okay, and roll back all the ones that have been done if everything is not okay. Okay, so I'll give you an example of why this is necessary to insert like that. Let's say in a bank, especially in applications where you need to debit an account to create another account. So I want to transfer money to your account, and the system first has to check your accounts to see if you have that amount of money that I'm trying to transfer into the next account. You have to check the account numbers if they're correct. So there are lots of checks that goes on before. Now, if the amount of money I want to transfer in that transaction is less than or equal to the amount of money I have in the account, then the transaction will go through. When a transaction is going through, things have to happen simultaneously. It has to deduct the amount from my account, and it has to add the amount to the other person's account. So all of these 3 operations must happen together or fail together. It will be disastrous if the bank application database is created such that it deducts the money from your account, then it doesn't credit the other account. Then that's when the rollback takes place. If it fails to credit the other account, you want it to roll back, and that deduction that happened to your account will come back at some point. So that's when we do transfer and the other person never receives the money and it deducts from your account, at some point you see it comes back there because it has rolled back the transaction, comes back to your account. And once it's all successful, yours is deducted, the other person is credited, it must have seen a commit statement to say, okay, now we can make this final. All of this happened, they all went smoothly, let's commit this. It didn't go smoothly, the commit is never done, and when you refresh that system, it just rolls back that transaction that was not completed. Okay, so that's the importance. So for insert statement, especially in those complex applications where there are things that must happen simultaneously, we wrap them in transactions. So in this one, it's not compulsory that creating the roles and permission must happen simultaneously, but I want to use it to illustrate. And I will advise you to watch the transaction in the week 4 video, which gives you a more detailed way of creating. That's what I expect to see in your assignment. And when you use inserts into the tables, I want you to use transactions to give those nicknames just the way it was done in that. And that's the best way to do it. But we're going to use an easier form of creating transactions here. And then in part 3, we're going to make it more complex when we look at stored procedures. Okay. So we start transaction and then we commit. But between the start transaction and the commit, we want to put all the transactions that we want to do. Basically, we use it for operations like inserts and updates transactions. You don't use it to create database or to create tables, just for those inserts and updates that must happen together or fail together. We want to insert into the rows table, and the rows table has, let's look at the table, has the columns ID, role ID, and row. So we want to insert into the role ID and the row column, since the ID is auto increment. So we'll say role ID and row. So when we say insert into the name of the table, then in a pair of parentheses the columns we want to insert into, and then we write values, and in a pair of parentheses the values we want to insert there. So let's say the value we want to insert, let's say this role ID is role 01, and then the value of this role, let's say, is patient, right? Then let's insert again into another one. Let's create several. You can make the values as a comma separated list, but I'll break it down like this so that we don't get lost. Admin. So we have two different kind of roles that we have created, the patient role and an admin role. Then we want to also insert into the permissions table, and let's say the table name is called permissions. So insert into permissions, and in permissions table we have columns like the permission ID, and the role. So we say here we want permission ID, we want the permissions, and then the role associated. For this, let's say the permission ID is voucher will be, let's say, perm 01. The permission, let's say one of the permission we have is account creation. So let's say account creation like this. So anybody who has the account creation permission will see on the menu on the drop down to be able to click to create account for another user or a patient. And then the role that is going to be assigned when it is being created, normally we want to use role ID and reference the role ID here rather than the role itself. But when we define this is the role we are referencing and not the ID. And so let me just reference the role and say this account creation should be for admin. It's the same thing. In production, we're not going to do it this way. If we have two like this and we have a list of choices, we might just use enum to make sure we keep this not free fields. But since we are typing this and we're sure of what we're doing, I'll do it this way. Okay, normally we just refer to the ID from the role table, but I created the tables. I'm trying to use the role itself, not the role ID. I want to insert again, let's say perm 02, and the next permission I want here is, let's say, appointment scheduling. And let's say this is going to be for, let's say, patients. Let's assume that patients schedule their own appointments online. They have the app where they can create appointments based on the available dates that will be displayed on their page. Then let's say we have another permission that we call request information. And this permission is going to be, let's say, for patients. Maybe the patient wants to request information for something. Let's have another permission, and let's call this permission record arrival. So when the person who takes the vital signs, will do that like that. So it's going to be an admin person. We want another permission. Let's call it perm 05, and let's say this permission is going to be create notes. Let's say this permission is going to belong to an admin also. We want another one to update information, and this will also belong to an admin that can update the information of the client. And then we'll have another one, let's say update notes, and we'll give this only to the admin who is a doctor to be able to update clinical notes. Okay. And then let's say we have another one called view appointments, and let's say we have an admin that can view appointments but cannot create one. Okay, let's stop here. The thing is, once you have the requirements, you're going to do all of this like this, and then you're going to fine-tune them as your requirement says. But this is the basic idea, and this basically actually has almost answered your assignment 3 question. But you're going to do your transactions the way I did it in the pre-recorded video. So we start transaction, we insert into all of this at the same time. Let's try to insert into the users table and the user permission within the same transaction, and then we'll just commit everything at once. But the user and the user permission table does not relate to this. We can commit this and do another transaction, but I'll just do all at once. So let's say insert into the user table. So we have insert ignore statement, so that if that already exists, it doesn't halt that, give you an error that it already exists. You can insert twice because of the primary key is duplicate. You can use insert ignore, but we'll use just insert here. So let's insert into users. Another thing you need to take note of is when you have foreign keys, you want to put your statements in the order of the foreign key. The parents come before the children, so you don't get errors. So once we insert into the users table, let's look at what the users hold. The columns are email, password, and role. So let's say insert into users. We want it to be email, password, role. And then the values will be, let's put an email as user1@gmail.com. This will be quoted because it is a string. Then the password will be, normally it will be encrypted, but let's just put user1pass. And then we want the role that this user is associated to here. And let's say because we use the role name and not the role ID, we'll just specify the role name. So let's say this user is assigned patient. Okay, let's insert into another user. So I'll copy this. So let's say we want to have 5 users. So we'll have user2@gmail.com, user3@gmail.com, user4@gmail.com, user5@gmail.com, user3pass, user4pass, user5pass. So let's say 2 are patients, 3 are admins. So let me make this admin. So now let's do that of the user permission. So insert into user permissions. The columns for this are the email and the permissions. So we'll have email and permissions. So the email, let's say user1@gmail.com. Let's say we have a comma separated or space separated list of permissions, depending on how the script processes the permissions from the front end and send it to the database. But let's assume that there's going to be a list of checkboxes that they will select all the permissions that they want to give the user, and then it stores in the database as a comma separated or a space separated list of permissions. So we have permissions here that we already have. So let's try to use these permission names here instead of the permission ID, and we'll say the permission this one is assigned to is create, account creation is assigned. This person is a patient, so no, let's only put patient's permission here, appointment scheduling and request information. So I'll put appointment scheduling here, and then I'll put request information. So we have the permissions for these patients, and we use space separated list. Then let's say the next set of permissions are for, let's use for an admin. Let's say user4@gmail.com. We want to say this admin only has permission to record arrival and view appointments. So let's say this is just like the administrator there. Let's say view appointments. So on the front end, only the permissions associated with a role will be populated once the role is selected for the user. So once the role is selected, then there will be a drop-down menu of permissions automatically based on when role is selected to filter the names of the permissions or the permission ID of the permissions that are associated with the role for the person who is creating the account to be able to assign the role and then assign the permissions one time. And then when it's time to update the user, you can also reassign permissions and revoke permissions. But that is for the part 2 of the course, when we later look, or part 3, when we are building our software, and we look at how to do all of this. Account registration, we'll create a login register page, and then we do all of that functionality. So now we see how to do this. I'll just put permissions for 2 users, and we want this permission to only succeed if that user exists. And so this should be in a transaction as it is here. We want to see if all of this happens. We want it to commit, which means that it will finalize it and insert all of this into the database. So I'll click on go. We have an error, unknown column permissions in field list. So we don't have permissions in the field list, and that is insert into permissions. So on the permissions table, what we have is permission and not permissions. So you see the error we have there. So this did not go through. We'll put permission, we'll change this to permission. Right, and then we'll click go again. And then there's a green tick for everything, which means everything works at once and it's committed at the end, after it all went through. If we want to look at each of the table, let's say select all from users. We're going to see all of the people in the user table. And to see that this is a foreign key, when we click on patients, it will take us to the role table where the parent is and see the role ID. So it is properly linked together. So if we look at structure here, we'll be able to see where the primary key and all of the indexes for the tables are. And we want to look at relation view here. Let's look at relation view for the whole database. Let's see. There's where I can look at all of the relation designer, and then we can see how they are linked. The users table, we can see how it is linked to this. The user permission is a foreign key for this, and we can see that from the rows table is linked to the permissions and the users are referenced here. So you can see how the designer is. So if you are somebody who creates a model, maybe your job description is to create this model and this link for the database administrator to actually come and sit down and now create the tables. This is the job that you do. You will draw all of this design and then you do it. But because we've created it, the PHP-MyAdmin automatically creates the design that we have done already for us to visualize it, to see this is how the tables are linked together. Any question? Does everybody understand this? Okay, in the absence of question, it means that it's clear and understood. If at any point during your assignment you need help, you can book a one-on-one, ask questions in the group chat, and we'll be there to help you. So we've looked at how to create database tables, insert records using transactions, all at once. We want to look at how to create views, which is part of your today's upload. And a view is just like you want to link two tables together, but you don't want to do that all the time. So you don't want to write joins all the time. You want the view to be created. You cannot insert or update a view, but it automatically populates from the tables that are referenced in the view. And you will use view a lot when you create enterprise systems. For those of you who are selected for the upcoming internship that starts on Monday, you will be doing a lot of this. And for those of you who are not future internships, you try to apply and see how the real world actually works. Okay. The view is going to be created. It has the same namespace as a table, so the name of a view must be different from the name of a table. And when we create a view under this, we're going to see something called views here, and it's going to list the views that we have. So let's say we don't want to go to the users table and then go to the user permission table to view the permissions assigned to a user, the role the user has. We want to just create a view, which is like a table, but not a table on its own that we have to insert into. It's going to be something that automatically populates based on the data in the table. We create a view like this. The same way we create a table, but we do create or replace view. We use create or replace, so if the view exists, just update it. If it doesn't exist, create it. So create or replace view, we want to put the name of the view. Let's say the name here will be, let's say we want people as a name, or you want to say full users, whatever you want the view to be named, but it must not have the same name as a table name. So create or replace view people has. So how do you want to, where do you want the data for this view to come from? After has, you put it here. I want to create this view from the users table and the users permission table to be in one table we call a view called people. So I want to say has select a dot, on the users table we have email column. So let's say a dot email, a dot role. Then let's say from the permissions table we want or from the user permissions table, sorry, we want b dot permissions. Then we'll say from users a inner join users b on a dot. So what common column do they have? Email on a dot email is equal to b dot email, like this. So we're creating a view, and we want this view to be a table that merges the information from the users and the user permission table. So when we want to use this in our software development, we don't have to write queries. We just select all from view to get all the information that we want in one statement. So when I click on go, if all is well, it will go through. It is not going through because there's no column called permissions. The column name is called permission. And so when you say go, it still has the problem, b dot unknown column b dot permission. And let's look at this. So we do not use the users a inner join permissions b, not permission. So we're using the permissions table. So the name is permissions. So inner join permissions b on a.email is equal to b.email. Now we say go, and we still have an error. Unknown column b.email in the on clause. So let's read it carefully again and see where our error is. So we create or replace view people has select a.email, a.role, b.permissions from users table A. We want to inner join. We are not joining the permissions table. We are joining the user permissions table because the permissions table has no email role. So take note of the common mistakes that you have. The tables we are using are the users and the user permissions table. So when we do the inner join, we want to look at what this A means is users and what the B means is user permission. So both of them have a predicate or a common column, that is the email column. And so when we correct all of this, we click on go. The user permission has permissions. Okay, we click on go, and then we have a green tick, which means we have created a view. When I refresh this, I'll see something called views here. When I click on views, we'll see people view, and then I can see the data of the different people merged together. The email address, the role the person is assigned to, and all the permissions for the person. So the same thing, we can create a view called appointments if we have the appointment table, and then we can see the email and the appointment date of the person, or you want to get a history of all appointments, a history of all vital signs. We can create views like this. So we don't run queries between that. In the back end, we just select all from the view that we have created previously. Any question? So following our business requirements, it means that we still need to create a table that will hold appointments that will be created, and a table that will hold vital signs that will be recorded, and a table that will hold clinical note information that will also be recorded for the patients. Now, I want you to use the same pattern to create these 3 tables as your practice. If you want us to review privately for no grade, you can actually do this and send what you've done via email or WhatsApp, maybe on a PDF file, for us to tell you whether you're right or wrong your queries to complete this task. So I want you to do that. So basically, this has already given you an idea or practically answered your assignment 3 question on what we want you to do. But we want it in better details, and it has much complexity as was done in your pre-recorded videos. We just use this to get you started properly. Anybody with question? Okay. So in the absence of questions, you have your part 1 quiz already released. Try to do the quiz. For those of you who have taken this course and dropped out and have written the quiz, you'll see the answers you have recorded in your previous quiz that you've done. Just update those answers if you want it, if you review it and you think that they should be different. For those of you who are taking the course for the first time, you'll see blank screens, no answer selected previously. So what we try to do is to remind you of how you answered the question previously when you took the course the first time, and you decide if you want to keep the answer or you want to update the answer based on your recent understanding of the task. So assignment 3 is due next week, and the quiz is for 1 week. It's not timed. You can start, look at the questions, go research, come back, answer the questions. Just make sure you save every question that you answer, so you come back there and always meet that, and you don't have to do it all over again. Okay? So this is where this lesson ends, and this concludes part 1 of this. This is the basic of MySQL. We want you to really watch the pre-recorded videos in details, as it has more details, and watch all the recordings of the live classes so far. And then next week we are going to introduce Python. So thank you, and see you all next week.
Thank you.
All right.
Thank you.
Thank you.
All right.
Thank you.